Regaco model Miniflex 600. This one is a very advanced model. Earlier, before this Miniflex 600 comes with the external chiller for cooling purpose.
The camera should not cover.
Come this side. You both are there to operate this? How come? One is not enough? This is not audible here. Maybe the voice also. Kylie, you want to come inside?
In this advanced model, there is a internal chiller. Inbuilt chiller is there for cooling the X-ray tube. So you can see here, this is complete thing is goniometer. Here X-ray source is there. Here shutter open and close indicator will come. X-ray will come out from here. Here we are keeping sample. So here we prepared one sample. This is a standard silicon powder. Okay, we have to keep like this. Okay. So X-ray will come out from this window. Okay, it will fall on this sample and it will refract and it will go to the solar slit. Here detector is there. This one is a semiconductor detector. Okay, it is a very fast detector. This can go up to 100 degree per minute also, scan speed. Earlier they were using some 0D detector. That is a 10 or 15 degree maximum speed. This one is 100 degree per minute. Okay, and intensity also more in this detector. Okay, so now I will start this machine. This is off button, this is on button, this is for emergency switch. So this is high voltage enable, this is the door lock, off and on. You have to switch on this. So this is blinking now. Now you can open the door, but you should lock it now. You have to press this, it will get locked. Now there is no blinking. Okay, now the chiller is in off condition. You can see here, chiller is back side of the machine. It is inbuilt. Somebody can come and see. See, this is the water tank. Chiller, inbuilt chiller water tank is there. This is the air vent. You have to fill the water in between L and H. This is a lower level. This is a higher level. Level should be in between this. You can see the water level. You can see that. And here, this port is for filling the water, or it can drain from water. Every 6 months you should change the water. So now this chiller is in off condition. When you start the X-ray, so this is the socket for this Regaco Miniflex 600. Just you have to open this. Here you have to enter the password. Distilled water, DM water. No, that I showed it, no? Here. Now one. You have to connect this pipe here. Here, inlet, outside
for the
is
in charge. It's in the afternoon.
inlet.
So you can see where you can get the proper videos. You're from mass
You have to
communication.
connect this.
Chemist.
You have to keep
Chemistry.
top of
You've been
this
given this.
here.
Masters.
So then
First year, second year.
to release that cap, and here one, this one is there, a tap. We have to open it. You have to open it. This water will fill. So up to this level, maximum level only, you can fill it. Afterwards, you have to close this and remove the pipe. When you are draining now, you have to keep it down. With the same port only, you can release the pipe. You should keep it down also. Otherwise, what will happen? So when filling, you should keep it up. Then only water will come. If you are keeping down and filling it, it may not be possible. Okay? This is air vent. You can see. No, just air vent. One over there.
How projects, no?
We are done.
You're done with the project.
We went out.
Oh, it is like internship. Where did you go?
PPS bank.
What are your plans after this?
Okay, you can see the software here. So we have to start X-ray now. Okay, now you can hear. Hello, you can hear now? Yes. Okay, we have to start the X-ray. You should go to startup and shutdown. So here we made one table because slowly we have to increase the X-ray power. So that we have done it in automatic process. You can see here. See, minimum voltage is 20 kVA and 2 milliamps. Okay, it is holding at 2 minutes. Then it will go to 25 kVA. First it will increase the voltage up to 40. Then after 40 voltage, current will increase. See, 2 and 5, 10, 15, 15. See, this miniflex 600 means it is a maximum power of 600 watts. So 40 into 15 is a 600. So I made this table. Just say OK. You run it. Automatically it will run. It will switch on the X-ray. Before switching on the X-ray, this chiller will start. You can see here now. See, chiller started now. Now X-ray will switch on. This will take 13 minutes. Easily. You can see the indicator X-ray on, X-rays are on. You have to wait for some 30 minutes till the maximum power will come. If you have any doubts about this XRD, you can ask me. Anyway, time is there.
How is the sound recognition?
Yeah, I can show you. See, we have two sample holders. This depth is around 0.5 mm here. This one is 0.2. So, if you have enough powder, you can use this sample holder. Suppose if you are having small quantity of powder, you can use 0.2 depth. So, how to prepare these samples? You have to take your sample and keep it in one white paper. Keep this. Then you have to fill the powder here and see. You have to make it like this. It should be flat. Okay. So you make it flat and remaining things, no, this powder, you clean it properly with IPA. With IPA. IPA, isopropylene alcohol. Okay. So same thing. But suppose if you are having metal samples, no, that time you can use aluminum sample holder. See. Suppose if you are having metal sample, solid samples, you cannot fill in this, na? That thickness may be different. So you will get some clay, some small children, they are playing, no? You have to bring that clay, keep that clay here, fill it and put center of this your sample, then make it flat. You keep like this and fill that clay and put your sample center of this sample holder and make it flat. It will become flat, no? Like this you have to keep. This surface should be flat. Bottom no problem. Nothing will happen. This top surface, no? It should be flat like this. Whatever I prepared on sample there. One layer.
When you keep it inside, you are keeping it along with the clay.
Along with the clay only you can keep. Nothing
Should
will
we
happen.
keep this upon something? Because
No.
does it hold the clay?
Yeah, there one spring is there, na? No, keeping inside there is a spring, but clay will stick, no problem. Here when you are filling clay, top of center of this you have to put your sample. If you have clay, I can show you. If you have clay, no.
So just clay here and the liquid sample on top. What I'm telling is, if you put clay, doesn't it fall down? That is
No,
because
no,
of the
it will stick,
pressure
na?
that we have put. It will stick.
It will stick. Clay will stick. Okay. Still 8 minutes is there.
Is there any number of the quantity in which we need to load the sample? Like you told regarding the depth. But say if 0.5, but we need to weigh this much.
No,
How do we know that it is compactly valid?
No, not like that. Just you pour the powder, make it flat. It should be in this area. It should be flat. I don't know how much quantity it will take. Just you fill the powder, make it flat with this plate. Okay. suppose if you have a still small quantity, one more sample holder is there.
Point.
This is called a low background sample holder. See, background will be very less in this sample holder. This is sample holder only. So if you have a very small quantity of sample, you can fill in this.
This will work even for liquid samples or this is only
No,
for
no, no,
powder
not
samples?
liquid,
Only
only
powders.
powder samples. But when it is this much of small quantity, no, that divergence slit you have to make it narrow. Now it is 10 mm. I think this one is around maybe 5 mm or 3 mm. 2 mm divergence slit you have to put there.
But the procedure is same, no? You
Same,
put
same.
there and
Yes, procedure is same. So where the space is more, no, that should go in that clamp. Here space is more, no, like this you have to put.
this side can be used again for powder other samples. Can be used.
Yeah, this, even this side also you can use it, but it is less than 0.2 depth.
Point less than point.
0.2 depth.
It is on this side.
Okay. Okay, still 5 minutes is there. You can see here, here hardware status is there, no? See what are the slits we can use here, it will display, and what is the voltage and current now right now. See 40 kV is the voltage, 2 milliamps is the current now. So every 1 minute this current will increase.
How do you customize the slip size?
That is now default, madam. Actually, normally we are putting this slits only. So according to your depends on your sample again. See, I told you divergence slit. Now it is 10 mm. Is there. If your sample is very less, you can use 5 mm, 2 mm like that.
So that can be customized even
Yes,
before we
yes.
run the.
Yeah, yeah. And you can see the chiller flow is there. Huh? See, 4.4 liters per minute. If it goes less than 2.5, X-ray will try. for this software they are using one dongle key is here. Without this you cannot open the software. It is looks like pen drive. If you lost that now, then you cannot open the software. You should purchase whole software.
You cannot install in this.
We installed, madam. Without this key, it cannot
Nothing
open.
will work.
It is a key. Mahesh sir, how are you? Mahesh sir
Outside.
is there.
He's outside.
Outside.
He's there.
Uh, uh.
When the software was opening, there was a message that was coming that cannot load this software this thing because license is not there. What was that? When the beginning of the
No,
page,
if the communication is not there, that time only it will come like that.
2-3 messages came saying this feature is not there because there is no license. And then it's
That is, see, this software is common for all the XRDs, like even floor model also, it can be used the same software. But for this model which is required, that only it is there in that software. Remaining things they locked.
no, okay.
That key is there now. That key was, accordingly they made that key program. It is not loaded like that.
Yeah,
will
it
come.
will.
Yes. XRR or something is there. Those things it will not come. When you open the software, this here ready should come always. Now easing is running, that is what easing is coming now. Okay. If ready is not coming, then you have to restart the PC. Okay, this is completed now. So you can see the power now 40 and 15. So 40 into 15 is 600 watts. Okay. You can close this and you can open the door like even through software also. Here door lock open is there. Just you click this. See, you can open the door. Now you have to open the door and keep your sample there. Just to keep your own sample. Standard is there. There only you keep it. Just you remove and keep it once again. Open the door.
Same
No, it is open. So you can see that the silicon powder is there standard. You can remove and put it back, madam.
Same.
Same. You can see now X-rays are on only, but it will not come out. But shutter is closed. Indicator is there, no? Close indicator. Now X-rays are not coming out. When you start the measurement, otherwise, that's what I am telling you. It is a very safety, this one is there. You make it center, madam. Press it and make it center. Okay? Yes, close it. Okay, manually also you can press that button or you can lock it here also. See, now it is locked. Okay, we will start the measurement now. So, measurements, you have to go to activities. Here general measurement is there. You double click this, here it will come. Okay, again you double click this, window will come. Okay, in this window you have to give the details, start angle, stop angle, and width, scan speed, everything. File name also you have to give. See now, here, see I created one folder here, IRTech something. You can create separate folder. Okay, now I will put it here only. That is silica powder, na? You type it now, powder, POW. Okay. So, see, this your data will be in the RAS X format. Okay. You can convert whatever you want. ASCII, some other, this one is there. Converter is there, I can show you later on. You save it. See, you can start it from, minimum is 3 angle. Okay. So we will start it from 10 degree. We will stop it. 90 degree we can do. It can go up to 145. So whatever you want you can enter. So this step width is normally 0.02. Okay. See, you can see here 100 degree per minute also you can run at speed. It is coming here, na? 100 degree per minute. But normally we will run it at 20 degree or 25 degree. Okay. So you can see physically whatever you used slits now, you can see here. See, solar slit, incident solar slit is 2.5 degree. This is a scattering slit. It is 13 mm means it is open only. And you can see K-beta filter we are using here. For what purpose we are using K-beta filter, I think you knows. Anybody knows this? So actually we are having a copper source. Okay. To remove that beta means it is coming from your source. That can be removed from this K-beta filter. You can see there. I can show you. Madam, you can remove that. K-beta filter is there, na? Nickel filter is there. This side, receiving side. Can see?
Is it written, sir?
K-beta something is there. This side. This one. Nickel filter. K-beta. Can insert. Given 10 degree, no? 10 to 90, okay, no problem. This is 02. This one we can use, see how much time it will take, 9 minutes. So you make it some 15 degree, 6 minutes it will take. Okay, we can run it same. Okay. So this will be default only, scan mode is a 1D scan. Okay, this is scan axis is theta to theta. Everything will be same only. To run this, see run is command is here. You can run it. And now that shutter is open. You can shutter open. It is showing here. See, shutter open. You have to switch off here. Then one more switch is there backside, MCB is there. That you switch off. But when you switch off the X-ray now, but chiller will be on only up to 3 minutes, 4 minutes like that. You have to wait till that chiller should switch off. After that only you can switch off. But computer you can shut down it. But machine now, after switching off the chiller only, you can switch off the main instrument. That sound will be there. You can hear the sound, or you can keep it open here. This will become zero flow.
For each sample, this startup shutdown, that values has to be arranged.
Start up the raising. Raising.
Yes.
No, I only created that table. See, what will happen? You have to increase the X-ray power slowly. But when you are increasing, if I ask you to manually do it, sometimes you can go suddenly 40, 50. So that is what for automatic this one I made one table. If you run that table na, no need to change manually. So whatever time I given there, accordingly it will go.
So for example, if I wanted to run another sample after this,
Continue. No. See, no need to go to this one X-ray again. With the same, now 40-15 is there. See, after this analysis, you can put one more sample and you run it directly. General measurement. Every time no need to go to that X-ray, this one aging. Only starting morning, you are coming now, morning around 9 o'clock, you can start this aging. I think it will take maybe around 6-7 minutes maximum. Okay, after that you can continue with your sample.
so that protocol which has been set can be used for everything. For aging, that protocol can be used for every time.
Yeah, morning. Every day morning you can use it.
She was asking about the part where we enter the data for steps and speed and everything. That can we use the same measurement for all the samples? Or
No, not required. See, default I am using it. However you want. See, suppose when you go fast speed, some small peaks you cannot be identified. That time you have to go very slow. That is all depends on your sample how you don't know anything about that. You make it very fast. Then you go where the peaks will come. Then that particular point only you take it, scan it some that range, and slowly you run it. You can identify that peaks, even small peak also.
Otherwise, in which range you are coming through literature, if you get that, it is not.
Yeah, that.
See, minimum is 2 degree, maximum is 145. You can go up to that also. Nobody will go 145 degree. Maximum in 120 only you will get your peaks. Okay. Now it is completed. Just say okay. This data you want you want to check now, you have to process it, okay, this data. So for that you have to go for powder XRD. Here load the data. Where this one, na? This is your sample. Just open. So you can get two theta values here, height, so integral intensity, everything you will get it here. Suppose here now you are not using ICDD software. If you are having ICDD software, you will come to know that these peaks are matching to which element.
That is JCPDS file.
Earlier JCPDS was there.
Now
Now it become ICDD. But you have not
That is
purchased.
not there.
Not
Not
there.
purchased.
Only small demo software is there. Demo Rigaku software is there. I linked it. Just I will open and I will see. Show you. Go to phase identification. Here surge match is there. Click this. Okay. Here you can filter elements also, which is included, which is not included. Now I am putting unknown only. I am not particular included, not included. I am not doing anything. So this is whatever you want, you have to check mark it. Okay. See. I showed you, Rigaku demo software is there. That I linked here. Just I will go to run. Okay. See, here it is showing that 640D. This sample is 640D. Some standard, actually it is 640F, but here it is showing 640D. All both are same only. So this is the phase identity 220. I think
Yeah,
110, 220 like that. So you can create a report for this. Okay, just create whatever you require, just to check mark it and say OK. In PDF XPSL it will create a report. See whatever slits you used, everything is there. Which detector you used, okay, all the peaks will come like this. See, 2 theta values, peak list, everything, each and everything. In this, whichever is required, that only you check mark it. Unnecessary, why you are taking all these things. Now I check mark everything. Okay. So this is the processing, data processing. So it will be there at any time. You can open it and you can see. Okay, it will be saved in the D drive. If you want to take this data, some people they require some ASCII format like that.
Yeah,
No?
we have it.
Yeah. See, I will show you. Here one converter is there. You open this. See now see output file, which format you require, that you have to select. Many things are there. Which one you want, you select that. Then here now, which file you have to convert, that you have to select. Okay. After that, here this one is there. Here it is. After selecting only it will come. Where it will come. There it is there, no? You have to select this.
Convert selected file.
Whatever.
Convert selected.
It is in
But
which
yeah,
one?
that
RAS. It is in RAS only. We have to select some other this
for
one. XY format we can select. Huh? Where it is stored?
Here it is.
Yeah, that's right. So it is same this one. You can open it.
it will be same with the read.
You have to go there again. No, not that way. This one.
Yes.
Notepad I can open. XY values will come. So with this in Excel you are plotting the graph and giving to the customer like that. Some people will do that. Whatever you want like that you can. So XY values are there.
Won't we get that entire values, not only that? The plot.
It is there now. Madam. Every 0.02 degree that will come on angle. See here, XY. With XY values, they will plot the graph and they will take these readings and put it in the Excel. In Excel, they will make with these XY values, they will make one plot, graph, and they will give it to the customer like that. Somebody will do that. That can be done yourself. Okay. Okay.
What I was asking is, how those mini values are there? Won't we get all this height, this especially FWHM, that also we need to plot sometime?
No, that is not required, madam. Some people they will ask some FWHM of that peak. That time this is required. Full width of maximum. This is called half maximum. This, so many things are there. You only knows this. Who is studying physics and chemistry? This all these things I also told. I don't know.
Why is the instrument showing the X-ray on the thing still?
Huh?
Why is the instrument showing X-ray on still, even after the analysis is done?
No, X-ray is on only, no.
It's on only.
Yeah, X-rays are on
No,
only.
but we finished the.
No, measurement you finished, madam. Just it closed the shutter. But before that shutter, no, X-ray is on only now.
Okay, so now the shutter is closed.
Yes,
As soon as
shutter.
the analysis-
Yeah, you can see now. See. Shutter is closed only. Now, if you want to see inside the instrument, you go to home. Okay. Just you open it and see. Open it and see. That shutter is closed only. Indicator will be there, na? So when you start the measurement only, that
Shutter
indicator shutter will open. Otherwise, it will not start. Suppose now it is open condition only. Okay.
Those should not see.
No, you keep it like that only. Just you run.
Until it is
It
logged, it
yes,
will.
yes. It will show you something. Okay. If you have any doubts, you can ask. See, shutdown process also. This startup is there, no? Again you go there. Here shutdown run is there. While shutting down, no, not like this slowly not required. Just you shut down, run it. Slowly it will come down and it will shut off the X-ray. You can see here now. See again two options are there. XZ off means XZ control you should switch off. When you run this, X-ray completely it will switch off. Suppose set to minimum means it will come to 20 and 2 milliamps. Okay. it will ask you to shut down. Okay, you say yes, then X-ray will switch off, and that chiller will be on only up to 3 minutes. Now X-ray is on. Okay, but flow it is showing 4.4 only. Then still chiller is
Chiller will
on,
take
on because it will be hot now. It should cool. So 3-4 minutes that water circulation will be there.
So this analysis is done, no? Sample analysis is done.
Madam, one sample. Silicon powder only I did. If you have your sample,
I think there would-
known sample, you can bring it and run
Yeah.
it. See the result.
The animal thing is, where is it? It's not there. I know how. No. You go. Thank you, sir.
Okay, thanks. You shut down there. Shut down. Exit. You start the instrument. This is off button. This is on button. So you have to start it. So here inside you can see bone metal computer. And this one is a X-ray source, copper X-ray source. Here one shutter is there, and solar slit is there to avoid the scattering of the X-rays. So X-rays will come out from here. It will fall on your sample. This is your sample. Okay, it will reflect and again receiving solar slit. This K beta filter is to eliminate the beta rays from the X-ray source. It will come. That will be eliminated through this. And this is the semiconductor detector. So here you are keeping your sample. This is the sample. So here 0.5 mm depth is there. Take one more sample holder and fill the sample and keep it. Okay. Close this.